Hello, I'm Dr. John Mark E. Burgos, your teacher in General Mathematics. Our objectives for today are represent real-life situations using logarithmic functions, distinguish logarithmic function, logarithmic equation, and logarithmic inequality. Third, solve logarithmic equations and inequalities. Before we start our lesson, let us have an activity first. For each equation below, give the value of x. I'll give you 4 questions to answer, and I will give you 1 minute to answer the question. If you are ready, you may start now. Time is up. Let us answer the following question. In the first question, we have 2 raised to the power of 4 is equal to x. If you will think of the answer will be x is equal to 16. Number 2, 4 raised to the power of 3 is equal to x. To solve the problem, we have x is equal to 64. Number 3, 5 raised to the power of -1 is equal to x. So the answer will be x is equal to 1/5. And number 4, 16 raised to the power of -half is equal to x. To determine the x, the answer will be x is equal to 1/4. For our second activity, again, I have 4 questions for you to answer. For each question below, give the value of x. You have 1 minute to answer the questions, and you may start now if you're ready. Go. Time is up. To answer its question, number 1, 5 raised to the power of x is equal to 625. So what do you think is x? Yes, you are correct. The answer is x is equal to 4. Number 2, 3 raised to the power of x is equal to 1/9. So what is x? Yes, you are correct. The answer is -2. Number 3, 7 raised to the power of x is equal to 1. So what is x? Yes, you are correct. X is equal to 0 because 7 raised to the power of 0 is equal to 1. And number 4, 10 raised to the power of x is equal to 10,000. So what is x? Yes, you are correct. X is equal to 4. Now, what is logarithm? Let A, B, and C be positive real numbers such that B is not equal to 1. The logarithm of A with base B is denoted by logarithm of A with base B and is defined as C is equal to logarithm of A with base B if and only if A is equal to B raised to the power of C. Let us have our first example. Logarithm of 8 to the base 2 is equal to 3, in which 2 is the base and 3 is the exponent. If A is equal to B raised to the power of C, then C is equal to logarithm of A with base B, or in the exponential form, 2 raised to the power of 3 is equal to 8. In our second example, logarithmic form, logarithm of 125 with base 5 is equal to 3. In the exponential form, 5 raised to the power of 3 is equal to 125. In our third example, the exponential form 7 raised to the power of p is equal to 21. In the logarithmic form, the logarithm of 21 with base 7 is equal to b. Let us have an activity first. I will give you 3 questions and I will request you to rewrite the following exponential equations in logarithmic form. If you are ready, I will give you 1 minute to answer the questions. Now, let's start. Let us answer the following questions. Number 1, 4 raised to the power of 3 is equal to 64. The answer is logarithm of 64 with base 4 is equal to 3. Number 2, 2 raised to the power of 5 is equal to 32. The answer is logarithm of 32 with base 2 is equal to 5. Number 3, 9 raised to the power of 3 is equal to 729. The answer is logarithm of 729 with base 9 is equal to 3. For our second activity, this time, I will request you to rewrite the following logarithmic equations in exponential form. Again, you have 1 minute to answer each of the 3 questions. If you are ready, let's start now. To answer each question, number 1, logarithm of 5 with base 25 is equal to half. The answer is 25 raised to the power of half is equal to 5. Question number 2. Logarithm of 9 with base 9 is equal to 1. The answer is 9 raised to the power of 1 is equal to 9. Number 3. Logarithm of 27 with base b is equal to 3. The answer is b raised to the power of 3 is equal to 27. Always remember, in both the logarithmic and exponential forms, b is the base, such that c is equal to logarithm of a with base b, and if you're going to transform that into an exponent, that will be b raised to the power of c is equal to a. Number 2, remember that in the exponential form, b raised to the power of c is equal to a, c is an exponent. And in the logarithmic form, c is equal to logarithm of a with base b, c is also equal to the logarithm. This implies that the logarithm is an exponent. Hence, logarithmic and exponential functions are inverses. Number 3, always remember that in the logarithmic form, logarithm of a with base b, a cannot be negative. Number 4, always remember that the value of logarithm of a with base b can be negative. Now, let us define common logarithms. Common logarithms are logarithms with base 10, where logarithm of a is a short notation for logarithm of a with base 10. Let us also consider natural logarithms. Natural logarithms are logarithms with base e, which is approximately 2.71828, and are denoted by ln. In other words, normal logarithm of a is another way of writing logarithm of a with base e. Let us proceed to the next objective, which is representing real-life situations using logarithmic functions. An earthquake is measured with a wave amplitude of 392 times as great as a sub-zero. What is the magnitude of this earthquake using the Richter scale to the nearest tenth? The Richter scale is a base 10 logarithmic scale which defines magnitude as the logarithm of the ratio of the amplitude of the seismic waves to an arbitrary minor amplitude. M is equal to logarithm of A over S, where A is the amplitude of the earthquake recorded by the seismograph taken from the 100 kilometer or approximately 100 kilometer for the epicenter of the earthquake, and S is the standard earthquake whose amplitude is 1 micron approximately. The magnitude of the standard earthquake is M is equal to logarithm of S over S is equal to logarithm of 1 is equal to 0. Another representation in real-life situation of logarithm is the sound intensity. To give you an example, one hot water pump has a noise rating of 50 decibels. One dishwasher, however, has a noise rating of 62 decibels. The dishwasher noise is how many times more intense than the hot water pump noise? Sound is measured in a logarithmic scale using a unit called a decibel. The formula looks similar to the Richter scale, where d is equal to 10 logarithmic of p over p sub 0. Now let us proceed to the next objective of this lesson, which is the distinction between logarithmic function, logarithmic equation, and logarithmic inequality. To give you an example of a logarithmic function, g of x is equal to logarithm of x with base 3. Another example is h of x is equal to logarithm of x with base 25 hundredths. One example of logarithmic equation is logarithm of 32 with base 2, which is equal to 5. Another example of logarithmic equation is logarithm of 64 with base 4 is equal to 3. To give you an example of logarithmic inequality, the first one is normal logarithm of x raised to the power 2 is greater than the square of normal logarithm of x. The second one is logarithm of 2x plus 3 with base 2 is greater than the logarithm of x minus 2 with base 2. For the function of the form f of x is equal to logarithm of x with base b, where b is greater than 0 and b is not equal to 1. Examples are f of x is equal to logarithm of x with base 5 and g of x is equal to logarithm of x with base 2. In an equation involving logarithms, the examples are logarithm of 27 with base b is equal to 3 and logarithm of 11 with base 121 is equal to 5/10. In an inequality involving logarithms, logarithm of x with base 3 is less than or equal to 5. Second example, logarithm of x with base 4 is greater than or equal to 6. Let us have an activity again. This time, I will request you to identify the following examples if it is a logarithmic function or a logarithmic equation or a logarithmic inequality. If it is, or if your answer is a logarithmic function, press the like reaction. If your answer is logarithmic equation, press the heart reaction. And if your answer is logarithmic inequality, press the wow reaction. If you're ready, let us start now. Number 1, the logarithm of 3x plus 2 with base 5 is less than the logarithm of 2x plus 5 with base 5. You have 5 seconds to identify the question. Start. All right? The answer is a wow reaction. You are correct. It is logarithmic inequality. Second question. The logarithm of 3x plus 6 with base 2 is equal to the logarithm of 27 with base 2. Is it a logarithmic function, a logarithmic equation, or a logarithmic inequality? You have 5 seconds. Go. Yes, you are correct. It is a logarithmic equation. Number 3. X is equal to logarithm of negative 3 with base 2. Is it an exponential function, an exponential equation, an exponential inequality, or this time, is it none? You have 5 seconds. Go. Yes, the answer is none. Number 4, h of x is equal to logarithm of x with base 7. Is it an exponential function, an exponential equation, an exponential inequality, or none? You have 5 seconds. Go. Yes, your answer is correct. It is a light reaction. Lastly, the logarithm of 4x minus 3 with base 5 is less than 3. Is it an exponential function, an exponential equation, an exponential inequality, or none? 5 seconds. Yes, you are correct. The answer is an exponential inequality. Let's proceed to our question and answer. If you have any questions, please post it in our FB Live. We have a question here coming from the audience. The question says, what are the restrictions on logarithms? Now, here is the answer. The base b in a logarithmic function must be positive. For exponentials, this condition assured that outputs from b raised to the power of x were always positive. For logarithms, this is a restriction that says the inputs must always be positive. Logarithms live entirely to the right of the y-axis. Thank you so much for listening. I hope you have learned something for this day, and may God richly bless you.